So today I'm going to show you how to better know a function. And by that I mean explore a function by changing the parameters of the function to see how the function changes. So for example, here's the logistic growth model in your textbook, and here's a version of the logistic growth function. And this function has two parameters. It has k, the carrying capacity of the population, and R is the intrinsic rate of growth of the population. And what we want to know is if we change K and R in different combinations, how does it change what this function looks like? So the first thing I'm going to do is I'm just going to copy and paste that function into a spreadsheet. So there it is. There's my screenshot. So let's grab it. And let's open my spreadsheet. And I'm going to paste it in there. There we go. And we want to start with an initial population size. So let's call that 100. We want the parameter K, and we want the parameter R. And we can write what these are. Initial population size, carrying capacity, and intrinsic population growth rate. All right, so let's make K say 1,000 and R something like 0.5. All right, how about 0.2? We'll play around with that. So here we have generation and N. So in the first generation, N is that number. And in generation 1, let's make a number of generations. So I'm just going to fill this down. I don't know how many generations we need. We'll have to play with that as we explore the function, but let's make 100 to start with. Okay. So if the function is dn dt is equal to this is the change in n over each generation, then this is equal to dn of the current generation. Let's make it like this. D or N1 minus N0 equals that. How do we want to do this? N1 minus of the previous generation. Let's make it explicit. Nt minus Nt minus 1 is equal to right-hand side. And that makes Nt equal to Nt minus 1 plus right-hand side. So there's the equation that we can use to model this. So this value, we put an equal sign in because we're going to use a formula, and we click the cell above it, which is the population size in t minus 1, the generation before, right? So that value is this value here, and now we need to add the population size, which is this, which is R. So we click in the value for R times N. So we click in the value of N, which is above, times K minus N. So that's this value minus this value divided by K. And that's that value, right? Now, notice that if we fill that formula down by grabbing the handle and dragging down, all right, the first, our N, B12 is correct. We're going to refer to the population size in the generation before, all right? But our R has also, the reference to that cell has moved down, and we don't want that. So we want to maintain, in this formula, we want B8 to stay in row 8 as I drag down. So I'm going to put the dollar bill sign in front of that 8. And B7, which points to that cell, we want that cell to stay constant. As we drag down, we don't want the 7 to become 8, then 9, then 10. So we put a dollar bill sign in front of the 7, right? And there's another B7, so we need to put the dollar bill sign there.